Today we're going to look at exponential growth and decay models. The first equation formula is y equals a times 1 plus r raised to the t. 1 plus r is known as the growth factor, and r is the rate of growth. R is always the percent written as a decimal. So remember, if you have something like 13%, that is 0.13. If you have something like 5%, that would be 0.05. If you are not very good at converting from percents to decimals, put the percent divided by 100 in your calculator, and that will tell you what the decimal needs to be. A is the starting amount. So you might want to label that that is whatever you're starting with. R is that growth or decay rate, and t is the amount of time. Notice between the growth and decay model, these things are exactly the same. A times 1 plus r to the t, a times 1 minus r to the t. So with growth, it's addition. With decay, it's subtraction. So the value of a car in thousands of dollars can be approximated by the model y equals 31 times 0.92 t, where t is the number of years since the car was new. We need to decide, is this exponential growth or decay? So think about yesterday. To decide if it's growth or decay, look at the number being raised to the exponent. That is less than 1. That means that this will be decay. Identify the annual percent increase or decrease in the value of the car. This is the kind of weird thing. We ended up with 0.92 in this equation. But that came from doing 1 minus r. Because this is decay, you're using that decay model. So that 0.92 came from doing 1 minus the percentage rate. So you might be able to think of this backwards. If you take 1 minus something and you get 0.92, what was that thing? Or you can solve this. But basically, once you solve this, 0.08. You should get r is 0.08. That, as a percent, would be an 8% decrease. Really, think of this decimal 0.92. Think of that as 92%. So if you're keeping 92% of the value of the car, what percent of the car are you losing each year? You're losing 8%, because 92 and 8 would add up to the total 100%. So think of it that way, that 0.92, we're keeping 92% of the value, which means we're losing 8% of the value. Estimate when the car will be $9,600. Basically, you just have to plug numbers in. So, I don't know, pick something. We could pick 4 years. 31 times 0.92 raised to the 4th. That is 22,000. We want it to be 9,600. So let's try, I don't know, 10 years. That would be 13,000. This is the tedious part. So 15 years is too much. And then you can kind of zero in until you find, it looks like it's about 14 years. And yes, I know this part is tedious. I get it. Next problem. The population during a recent decade can be approximated by this model. T is the number of years since the beginning of the decade. Basically, this problem is just like the previous problem, so pause the video, try this problem on your own. I will get you started. Notice that 1.03 is bigger than 1, so this time it is growth. Try B and C and then check back in a few minutes. Okay, so first of all, sorry about this. It says value of the car. It should say the increase or decrease in population. So this 1.03 comes from that formula. Look back at your notes at the growth formula. That is 1 plus r. So 1 plus 0.03 That means there's a 3% increase in population. To estimate when the population was about 590,000, in my calculator, I tried 5 years. That gave me 573,000. I tried 7 years. That gave me 607,000. So then I narrowed it down to 6 years, which is right around 590,000. This does say estimate, so it's about 6 years. In 1980, about 2,180, that should say 1,000. Wow, there's tons of errors here. U.S. workers worked at home. During the next 10 years, the number of workers working at home increased 5% per year. Write a model giving the number W in millions of workers working at home T years after 1980. So the initial amount is 2,180 million. If we want to write that in millions, that would be 2.18 million. The growth factor is 5%. As a decimal, that's 0.05. Actually, no, the growth factor is the 1.05. The percent increase is the 0.05. So the growth factor would be 1 plus the 0.05. So basically, you're just using this formula, y equals a times 1 plus r raised to the t. Your starting value a is 2.18 million. 1 plus this r would be 1.05 raised to the t. And they wanted our formula. It doesn't say what they want it to be, so we can say y equals. Then, estimate the number of workers working at home in 1990. This starting amount, 2.18 million, was in 1980. 1990 would be 10 years later. So we are using this formula with a t value of 10. Oops. Plug that into your calculator. 2.18 3.55 million. For this one, we're going to be using a decay model. There are 40,000 homes in your city. Each year, 10% of the homes are expected to disconnect from the septic systems and connect to the sewer system. That means that the number of people connected to septic systems will decrease by 10% each year. I want to see if you can write this exponential decay model. So fill in A, fill in R, and then use the model to estimate the number of homes using septic systems after 5 years. So try this one on your own and then play the video again. The initial amount A is 40,000 homes. R is 10%, so 0.10. If you use this as your answer, that is technically fine, but you can do 1 minus 0.10 to get 0.9. This makes it just a little cleaner, a little bit more finished. Then estimate the number of homes using septic systems after 5 years. You plug 5 years into T, plug that into your calculator. I got the decimal 23619.6, so I rounded that up to about 23,620, and because this is a word problem, we would say homes, and that is our answer. Our next formula is the compound interest formula, and really this is a very, very similar formula. There's just an extra thing in here. So P, instead of using lowercase a, P stands for principal, and that is still the starting amount. This time it's just talking about money. R is still the rate of increase. This time it's going to be interest rate because we're talking about putting money in a bank account and that amount increasing with interest. N is the number of times the interest is compounded each year. So if they say it's compounded annually, then n would be 1 because that's compounded once per year. Monthly, there are 12 months in a year, so n would be 12. Quarterly, think about quarters. There's 4 quarters in a dollar, there's 4 quarters in a year, so 4 quarters in a year. Weekly, there are 52 weeks in a year. Bi-weekly can actually mean two things. Bi-weekly could mean twice in a week. It could also mean every other week. It usually means every other week, so this would be 26, but I just won't really use that one. And then daily would be 365. You deposit $2,300 in a bank account, find the balance after 3 years. If the account pays 3.5% annual interest, let's do quarterly. So using this formula, our total amount is going to be whatever we start with, 2,300, times 1 plus, for R, we're going to use our interest rate, but we have to write 3.5% as a decimal. 0.035 divided by n, that's how often we compound. Quarterly, your n will be 4, raised to the n times t. So that 4 needs to go up here as well, and then t. The tricky thing about this is how to plug it into your calculator. So actually it says 3 years, so instead of that t, we can put in times 3. So to put this in your calculator, parentheses are your friend. 2,300 times, I use parentheses, 1 plus 0.035 divided by 4, closure parentheses, raised to the, in a graphing calculator, it gives you this field in the exponent, so you can do 4 times 3 in the exponent without worrying about it, but you might want to do that math in your head if you're using a scientific calculator, or you might want to use parentheses around your 4 times 3. You want to make sure that all of that 4 times 3 is in the exponent. That gives us $2,553. And let's round appropriately. This would round up to 47 cents. And label it properly with a $sign in front. Let's do monthly for the next one. Try the next one on your own. Okay, if you're struggling with this, you may want to pause on this screen because this shows all of the stuff and where it goes in the formula. So your starting amount, 2,300, parentheses, 1 plus your rate. Remember, if you're struggling changing percents into decimals, do 1.95 divided by 100. That will give you the appropriate decimal to use. Divided by 12 monthly, n equals 12. That 12 also goes in the exponent, and then the time, 3 years. I punched that into my calculator. You can pause the screen to see how I entered that into my calculator. This is the answer I got. We need to round properly. That means rounding to the nearest cent. The number after determines if we round it up or leave it alone. So our answer is $2,438.45. For this next problem, you need to put in what you know. The difference is how much would you need to invest? What should P be if we want to end up with $3,000? So keep your P in because you don't know what that is. Our rate is 0.052, compounded monthly for 6 years. Basically, figure out what this equals in your calculator, and then take 3,000 divided by that to figure out what P is. So pause the video, do that, and then play again. I entered this in my calculator, got this crazy decimal. You can round it. I would round it like 3 or 4 decimal places, but ultimately you'd need to invest about $2,200.